Okay, let's look at some other algorithms. So MapReduce algorithms for relational join, matrix multiplication, which can be done in one round, which means going through the data once, or 2 rounds. Relational join, this is join operation that you will do in databases, or if you have 2 tables and you want to join them, they are called relations in this case. So let's say we have a table, the first table is a relation, it has attributes A and B. We want to join it with second table called S. You could say that that's S because of the system. And it has attributes B and C. So, what we can see here is that there is a common attribute here. So, this table joined with that table, there is a common attribute. So, we want to produce a joint table with all of the 3 of them, A, B, and C. So we're just running the join operation. How are we going to do this in MapReduce? So we can use a key and map each record or tuple or row of the first table to the key B. The value for that will include the relation, the table that it came from, and the other attribute A. And the reason we're using B as a key is because the B here was the common attribute. So the key will be B. R is given in the value, and it's just a bit. Which is saying that this record came from the first table, from table R. So each record or tuple is mapped to the key in the second relation. Each tuple is mapped to the key B, and in the value the same thing. We give the table where it came from and the other attribute that it has. Well, the second table S had B and C as attributes. So we will group by keys, and each reducer will get, so the map function will group by keys, and each reducer will get a key list that looks like this. For B, for the first tuple, let's say 1. So B is the key, and there is a list for the first tuple, the second tuple from relation R, and then first tuple, second tuple from relation S. So what is the reducer function going to do? So for each pair that it gets on the list, we'll emit A, B, and C because we want to join them, so we want to have a table that has both A, B, and C. So this process will produce a large large number of outputs, which is quadratic number of outputs, if it's function of the whole list length. So we could consider this as a parallel join, parallel hash join. This could work if we don't have too many tuples with the same shared value. So that's how we join them. So now we can look at an algorithm that will do matrix multiplication so if we have two matrices M and N, each one has values Mij and Jk. Then we want to produce the multiplication of those two. So we can go through the data once and do something similar to what we did with the join. And the second pass, we will do group and aggregate operation. So if those tables or matrices are very large, then it's possible that a lot of the values they contain are null. If that's the case, then we consider them sparse relations. So this group and aggregate operation will be efficient, very efficient, if we have this kind of sparse relations. So how is the map function going to look like for multiplying these matrices? So as a key, we will take one of the elements, in this case element J, and then the value, the matrix that it came from, I and Mij. So this is from the first matrix. From the second matrix N, we as a key will take again J, and then the value K and Jk. So for this key J, we will pair each of those values or lists that we have with each and produce another key called Ik. That's in the reducer function. So the value in this case will be the multiplication of the two elements. The first one is from the first matrix and the second one from the second matrix. So the key for the reducer will be Ik, and the value will be the multiplied elements of those two matrices. Then we'll do another pass because we're doing join and aggregate. And so in the second pass, the result is that each key is paired with a list of products. The reducer function will sum all the elements on the list and produce a key and a value for that sum. we're going through it twice is because we're making it more efficient with this join and aggregate functionality. Let's look at some other